From the ground, the night sky looks calm, but above these cities, an unseen shield is watching every approaching object.
Because these high-value assets are large and stationary when deployed, they are often protected by short-range systems fighting low-altitude threats and drones. Deployed abroad, these systems not only protect local assets but also send a political message about Russian presence and commitment.
Modern wars no longer begin with the roar of tanks. They begin with silent dots on a radar screen, moving at tremendous speed.
Aircraft, cruise missiles, and ballistic missiles can cross continents in minutes, forcing nations to build deep and layered air defense networks.
Low-flying cruise missiles hide behind terrain and the curvature of the Earth, seeking gaps in radar coverage and reaction time.
To protect these cities, you need systems that can see far, think fast, and strike accurately at long range.
This is the S-400 Triumph, a long-range air defense system designed to form one of the key layers of Russia's aerial shield.
In the past, air defense meant guns and simple missiles fighting aircraft that flew relatively low and slow.
Today, aircraft launch weapons from hundreds of kilometers away, staying outside traditional anti-aircraft gun and short-range missile envelopes. Ballistic missiles rise into near space before falling back at several kilometers per second, leaving very little time for a defender to react.
To cope with all of this, Russia builds a layered umbrella that reaches from treetop level to the edge of space.
Within this umbrella, the S-400 forms the long-range backbone, watching hundreds of kilometers around key cities and bases.
A typical S-400 formation combined command post, long-range surveillance radars.
Command vehicle receives information from radar and higher headquarters, identifies threats, and assigns targets to individual batteries.
Long-range surveillance radars scan hundreds of kilometers in all directions, building a continuous picture of the airspace.
Inside, operators supermotion is continuous.
When a threat is confirmed, the fire control radar locks on, refines the trajectory, and prepares to guide interceptor missiles.
Each launcher truck carries several sealed canisters holding ready-to-fire missiles of different ranges and roles.
Long-range missiles inside these canisters are built to climb to high altitude, maneuver, and intercept fast and distant targets. The S-400 can employ very long-range missiles, medium-range weapons, and compact interceptors to build shorter-range missiles defend the inner zone, while the longest-reaching projectiles can attack valuable targets out to 400 kilometers.
These long-range shots are aimed at aircraft that coordinate attacks and provide radar and electronic support for strike packages.
Compact missiles allow one launcher to engage several targets at once, increasing the density of fire in the inner defensive ring.
Against cruise missiles, the S-400 uses precise tracking and guided interceptors to meet them head-on or from above before they reach their targets. In its terminal anti-ballistic role, it can engage some ballistic missiles in their final phase as they re-enter the atmosphere.
All of this information is fused into a single air picture that helps commanders decide which targets to engage and when.
The human element remains vital, as officers must interpret data, respect rules of engagement, and avoid fratricide or wasted shots. Once a battery sets up in the field, launchers are raised to the vertical position, ready to fire within a relatively short deployment time.
At launch, the missile leaves its canister with a powerful booster, then quickly turns toward the calculated intercept path as guidance takes over.
Guided by data from the fire control radar, the missile corrects its course many times per second as target and interceptor move through the sky.
Ideally, the warhead destroys or cripples the attacker at a safe distance, turning a precision weapon into harmless debris. Above the S-400, another system appears, designed not only to defend airspace, but to reach into near space itself.
This is part of the S-500 complex, built to detect and track objects far beyond the altitude typical air defense radars were created for.
The S-500 aims to intercept ballistic missiles and some satellites in low orbit, at altitudes where space and atmosphere meet.
Instead of waiting for a warhead to fall near a city, it seeks to destroy the threat at great height and distance from the target. Commanders monitor ballistic trajectories, possible decoys and re-entry vehicles, and must choose which objects to engage first. Missiles used in this system are larger and more powerful, built to climb higher and faster than traditional long-range surface-to-air missiles.
Open sources suggest interception altitudes approaching the edge of space, covering the final and sometimes middle phases of ballistic missile flight.
Future adversaries may deploy hypersonic glide vehicles that can change course at very high speed, and the S-500 is advertised as a response to this challenge.
The system is expected to track and engage many incoming objects at once, coordinating several interceptors in a very compressed time frame. At the strategic level, this means a hostile missile aimed at the capital might be destroyed thousands of kilometers away from the target.
Some sources even claim a limited capability against satellites in low Earth orbit, adding a space denial element to the system. To keep such a complex system operational, crews must constantly maintain electronics, mechanical structures and communication links.
Test launches demonstrate basic performance, but the system's real effectiveness will only become clear in prolonged operational use.
Because many details are classified or exaggerated, outside observers must treat claims about its full potential with caution.
What matters is how these systems work together, with S-400 guarding the skies and S-500 extending protection into near space. On the ground, this means separate complexes linked by data networks, exchanging tracks and engagement orders across a wide area.
Missile связь мякот.
Where S-400 mainly handles aircraft, cruise missiles, and some terminal ballistic threats, S-500. Around the capital, this architecture can be imagined as a vertical fortress, from low-altitude guns
Closer to potential front lines, shorter-range systems protect troops and infrastructure, while long-range and near-space systems guard key strategic directions.
For an attacker, each ring adds risk, forcing aircraft to fly higher, lower, or farther away, and to carry more specialized weapons.
By selecting the right positions, planners can block key approaches to critical cities, industrial regions, and missile bases.
No system is perfect, but layered defenses increase the number of chances to destroy or deflect incoming weapons.
Because these high-value assets are large and stationary when deployed, they are often protected by short-range systems fighting low-altitude threats and drones. Recent conflicts have shown that even the most advanced radars can be threatened by low-cost loitering munitions if they are not properly screened.
In places like the Kaliningrad enclave, long-range systems project influence over surrounding airspace, complicating planning for potential adversaries. On the Black Sea, such batteries can threaten reconnaissance aircraft, bombers, and possibly some cruise missile carriers.
Deployed abroad, these systems not only protect local assets but also send a political message about Russian presence and commitment.
Export of S-400 batteries to partners such as India and Turkey has influenced diplomatic relations and defense discussions worldwide.
Some buyers risk sanctions and political pressure, judging that enhanced air defense is worth the potential economic and diplomatic cost.
A hidden side of these systems is the constant work of technicians, without whom the most impressive specifications would mean very little in operation. Exercises measure how quickly a battery can move, set up, fire, and then relocate before it becomes a static target. In reality, these systems are only one part of a vast information web that includes space-based sensors and long-range.
Enemy pilots must always consider where long-range surface-to-air missiles are, and adjust routes and tactics to reduce exposure.
Strategists study these ranges and capabilities, searching for weak points, gaps in coverage, and ways to saturate or deceive the defenses.
Electronic warfare tries to blind or confuse radars, while modern phased array systems change frequencies, beam shapes and timing to fight back.
Stealth technology reduces detection range, but long-wavelength radars and networked sensors can still cue interceptors if the geometry is favorable.
No matter how powerful, a finite number of launchers and missiles can be overwhelmed if the attacker spreads and coordinates enough weapons.
There is also an economic dimension, as high-end interceptors may be far more costly than the drones or missiles they destroy.
Sustaining a credible shield demands not only technology, but also steady production and stockpiles of missiles and spare parts.
Given the cost and complexity, such near-space capable systems will likely protect only the most vital regions, not every border.
For the average citizen, this network is invisible. but its presence shapes national confidence and strategic calculations.
Inside planning rooms, these systems are part of a larger picture that includes nuclear deterrence and conventional forces.
As the boundary between air and space blurs, the importance of platforms that can operate in both realms will only increase. Future offensive systems will try to outmaneuver today's defenses, demanding new generations of sensors and interceptors in response. In this environment, the S-400 and S-500 represent snapshots in an ongoing technological and strategic race.
We designed these systems to prevent war as much as to fight it, by convincing potential enemies that attacks would fail.
Strong defenses can sometimes open space for negotiation by reducing the temptation to launch surprise strikes. At the same time, the spread of such systems drives other countries to improve their own offensive and defensive technologies. Training the next generation to understand these tools and their limits is essential, because even the best technology can be misused.
We have traveled from city streets to the edge of space, following the path of threats and the systems built to stop them.
The goal is simple to express, but difficult to achieve, to ensure that nothing hostile ever reaches this peaceful view.
In the 21st century, control of the skies and near space will define security, influence, and survival for many states.
For Russia, these systems are more than hardware. They are tools of deterrence.
And so, while the shield watches in silence, the most important victories remain the ones that are never seen, because attacks were never launched.